So yeah, these reds are usually oxygen, but we're just gonna pretend like they're also carbons. Just gonna be terbutyl. So yeah, when you have something like that, like anything like this, you just need to pick. I would just choose one, and I always choose my biggest, bulkiest one, and put it here in my equatorial. It makes it simpler to work with. Because if I chose to put my biggest, bulkiest one like in the middle, it's going to be hard to see. So what these dashes are telling us, they're all dashed, right?
Yes.
So it's telling us that they're all on the same plane. These are all.
Does dash mean they're way from you or what?
Well, okay, sorry. These are wedges. They're coming out at you.
Out of you, okay.
So this is what it looks like. It's saying like this terbutyl is coming out at you, the ethyl's coming out,
okay.
the methyl's coming out.
Okay.
Here, this one, the terbutyl and the methyl are coming out, but the ethyl, if I can make it flat, is going away from you.
Oh, okay.
And then here it's just flipped, now the methyl's going back. So, your question was, does down mean equatorial?
Yes.
Not necessarily. So, I'll keep, yeah, those guys.
It's like she said in class when you number the cyclohexane chair, you usually start the head at number 1, right? Usually.
In chair.
Good.
Yeah, usually you're going to say.
And so the way I remember it is, in the book you'll say, do an axial up on number 1. And then on the next one, do an axial down on the number 2 carbon. 3 go up, 4 go down, 5 go up, 6 go down.
For
Alternate.
equatorial?
For axial.
For
You put the axial ones first, and then you go back to the 1 and put in your equatorial, which is going to be the opposite of up, so it's going to be down equatorial. And number 2 will be an up equatorial.
They just alternate?
Alternate back and forth.
Yeah, if you just draw it the same way each time, you get good at like, the way I also remember it, like, I just go where the points are, like this one points down, up, down, down. And those are where all my axials are. How's it going?
To where the point.
Yeah. And it just depends on how you draw it. You can sit in that corner there. So, and then another way to see it, like here, notice the terbutyl, right, is down, the hydrogen's above it, and this one's an equatorial. If it flipped its conformation, now the terbutyl is down and it's axial. See how that?
Yes.
Where it's still down, and then if I flip it this way, now it's up. And so, what we're going to do is we're just going to choose, I'll put this one on the run.
So when you ring flip, it doesn't change the up or down, it changes
Axial.
Yeah,
and equatorial. So it doesn't
flipping its
change.
confirmation.
When you ring flick, so the equatorial will be axial and axial will be equatorial, right?
Yeah.
Okay.
So what if you turned it the other way? That's not flipped, right?
You mean like just flipped it
Yeah.
over? No, I mean that's just, because in nature, molecules don't care, they don't know which way's, high and low. I mean they could be flipped anyway, it's just all your perspective. So like on this case, so one thing what we're seeing here is we're noticing they're all on the same plane. Like if I put hydrogens, if you make the ring flat, so it's not in the chair conformation, and it's hard to do, you notice the ethyl, the methyl, and this guy, they're all on this side of the plane. The hydrogens to it are below the plane.
That's the first one?
This is what we're seeing here. Then, like this one, I would just switch the ethyl and the hydrogen. The ethyl will now be going away from you. Or you could say these are all coming towards you, but if you just flipped it over, they're going away.
Gotcha.
So what we're going to do is the terbutyl is the biggest one. So we want to put it in an equatorial position. Okay, and so now the methyl, we know that if this is equatorial and it's down, because the hydrogen's up above it, this methyl is also down because it's, sorry, go this way, go backwards. methyl here is also down and it's equatorial. And then the ethyl is down equatorial. So they're all able to be in an equatorial position. So that's pretty stable. Most likely this is our right answer. Then what we do for this guy, let's say we're doing this one here, the methyl is going to be cis to the tert-butyl because it
Yes.
wedge, wedge. So here, the tert-butyl, we're saying it's down, therefore being down here is also equatorial. But here we're saying this is dashed,
Yes, it's
so it has to be
away from that.
trans, so it must be up. So our ethyl is in an axial position. So this isn't very stable. Here, we had all of them in equatorial. In this case, this one's an axial.
When you get these ring problems, do you have to put them into chairs to be able to assess the stability? Like, to
Once you've done
determine?
it enough times, you can get good at it. If you just know, if this is equatorial, okay, here's a trick. If it's cis and they're every other, then they're all equatorial. If it's trans, like if I make these odd numbers, you just do it this way. And we say, okay, this is gonna be equatorial. Then everything that's cis to it on odd numbers are equatorial. But then they have to be trans or going away from it to be equatorial, if that made sense. Let me draw just like a big,
Aren't trans usually more stable than cis?
not in ring structures. Ring structures, we're only looking at equatorial versus axial.
Yeah.
Trans is more stable in a double bond. That's what, if you read that in the book, that's what it's referring to.
But I just mean, I